Welcome everybody, and welcome especially Jackie and Gary. If I can introduce both of them as the main people behind Solarbility, PV experts and other things, and ask them to start talking now.
Hello everybody.
Hi everyone.
So thank you, John. So as John said, we are Solarbility, and we're going to talk you through a presentation we've prepared. We're going to go back to basics and talk you right through from the beginning about solar PV. So forgive me if you're ahead of your journey, but a lot of customers are starting at the beginning, and I thought it was important to talk simply and right from the beginning. So I will share my screen. Everyone see my screen?
Yep.
Wonderful. Okay. So Gary's going to start by just introducing how solar has got to where it is today.
Yeah. Okay. So a lot of the questions we get obviously are about government grants and feed-in tariffs and that sort of thing. So it's kind of interesting to know, really, for residential homeowners, as far as I'm aware, in my 8 to 9 years in the solar industry, we haven't really ever had grants as per se for residential homeowners to buy solar. There were things like the Green Deal that came out, and they didn't last very long. They kind of sort of fell over quite quickly. But what we did have launching in 2011 was the feed-in tariff, which is what most people would have heard of. As we can see on the screen here, so before the feed-in tariff, less than 30,000 homes in the UK had solar, whereas other countries such as Germany, as we know, went ahead quite early on. I think their feed-in tariff was either halfway through or nearly finished by this time. So our model kind of copied theirs to an extent. It was quite successful in getting the industry on its feet, because today there's roughly 1.2 million homes which are benefiting from solar PV systems. Like I say, it began in around 2011, and back then you were paid based on how many kilowatts you could generate from your solar panel system at a really high rate. You were paid about 43p to start with. And then what the government did, when the Conservative government came in, if we remember around that time, they then reduced this for new customers, and it reduced down for new customers all the way up until 2019, where it was finally discontinued. These customers that purchased solar on the feed-in tariff back in 2011 were given the high rate of 43 pence per kilowatt for 20 years. And then people who would have purchased it in 2012 were given a contract for 20 years at the rate of 25 pence, and so on. And it went down. I think when I joined the industry, we were on something like 16 pence in 2013, I think it was. Oh, it's just quite 2014. Yes, it's been 9 years. And you know, those people today are continuing to receive feed-in tariff at that rate. So like I say, that went all the way up to 2019, where it's discontinued. There was a short pause where there kind of wasn't anything at all. The government was sort of scratching its head a little bit. And then in 2020, just before the coronavirus outbreak, they launched the SEG tariff to replace the feed-in tariff. Now, the difference between them is important. So the feed-in tariff was a set rate by government, and it was based on your generation. So whatever the solar panels had generated, you were paid based on that generation. Whether you used the energy or not, it was the gross amount that you were paid on. The SEG is actually just a net export tariff, and there's no set rate. So it's a bit like the free market now. So just as you shop around for your energy bills, you might go to British Gas and pay 28 pence a kilowatt for your electricity, or maybe Scottish Power, or I know a lot of people are with Octopus Energy. In the same way, you can shop around and find a better SEG export rate from the energy providers out there. The meters are now the property of the energy company. So you'll be given a smart meter, which is bidirectional. So not only will it will record any energy coming into the house as normal, it will also record the net amount of electricity which goes out to the grid, and then you'll be paid based on that rate. Now, as we've heard, you know, with big six energy companies, it tends to be around 5p. But I do hear, you know, some people with companies like Octopus, they can get like up to 15p. But it is variable, and it's based on the tariff that you agree. So it's not too bad. One of the particularly nowadays as well, we're not as limited. So when the feed-in tariff existed up until 2019, most people felt limited to be within 4 kilowatts or below. Otherwise, they'd get put onto a different tariff, more like a commercial tariff, which was lower. So today, most of the systems that we're installing are, you know, 5, 6, even 7.5, 8 kilowatts in size. So what they're actually finding is their export payments are actually quite high. A customer shared with me that he's earned £50, you know, last month. So that's not too bad, is it? So yeah, just a little bit about that. I know some people probably have more questions about the export tariff, but we've got an FAQ section afterwards. So we'll just continue through the slides. Thank you.
Okay, so that's led us up to where we are today. So let's go back to basics and talk about how does a solar PV system actually work. So what are solar panels? So a solar panel is a device that converts sunlight into electricity by using photovoltaic PV cells. PV cells are made of materials that generate electrons when exposed to light. The electrons flow through a circuit and produce direct current, DC electricity, which can be used to power your home, electric vehicles, and send surplus energy to the grid. Solar panels are arranged in groups called arrays. An array consists of 4 or more solar panels. So, for example, if you had a roof that you wanted 2 arrays on, so you had an east roof and a west roof, but the west roof didn't have much room, but the east roof had a lot, so you wanted to put 10 panels on the east roof, but only 2 would fit on the west, we wouldn't be able to do that. They need to go in sets of 4.
Yeah, that's right. Just to explain a little bit more there. So with the technology, you know, the panels are wired in series, so they need enough voltage to make that particular string or tracker, as we know it, you know, to have enough voltage to carry the current. So yeah, there's some slight limitations there on the design, but in most cases we find it's, you know, we can always do something.
Okay, so how do we actually measure electricity? So kW refers to a kilowatt. It's a measurement of electrical power, and it is 1,000 watts. An electrical item rated at 1 kilowatt will use 1 kilowatt of every hour of use. If you were to use that item for 10 hours a month, then your monthly electricity bill will be charged at 10 kilowatt hours, times the rate given to you by your energy provider. So kWp is the peak power rating. For example, a solar panel system rated at 4 kWp will produce 4 kilowatts per hour at its peak. So I'm going to have to move my screen, bear with me. When we estimate the power delivery of a solar panel system, we first look at the amount of panels that we can install on our target roof. For example, let's say 10 panels. The panels are rated at 400 WP, watts peak. So you have a total of a 4 kilowatt peak solar panel system. We then look at the location, for example, zone 1 for the southeast, then the orientation and pitch of the roof, and if there is any shading to the roof. So we are MCS accredited, so using the MCS microgeneration certificate scheme, they have a calculation. We can give an estimated annual generation for the solar panel system in kWh. So how do the solar PV systems work? So solar PV panels capture the sun's energy and convert it into electricity. The cells don't need direct sunlight to work and can even work on cloudy days. However, on brighter days, more electricity is generated. When daylight hits the panels, an electrical charge is created in the silicone cells, causing the electricity to flow. The electricity is known as direct current, and is the type that is created by electric motors and the type that's stored in batteries. The electricity that is used in our homes is known as alternating current. So we need to make use of the electricity from the solar panels. We need a device known as an inverter to change the direct current to alternating current. The inverter is connected to your home's electrical supply at the fuse board. So anything that is drawing power, be it television or refrigerator, the electricity from the solar panels will automatically go to power those electrical items.
Yeah, so one of the questions that I often receive is, oh, how do we, switch and choose where the electricity goes? Well, in fact, it's just instantaneous. So everything is connected in your home like one long piece of copper. The PV system is simply connected into that fuse board. So anything connected to that fuse board will just draw the power. If ever you speak to an electrician, they'll speak about that's drawing current. So that's exactly the way to think about it. If you switch on a light or a kettle or something, then that is going to draw the current to it. So that's basically, it all just works. If you think about it, all just working automatically. There's no switch gear. There's not a way to, well, there is, but there's not really a way to connect it to choose where the electricity goes to. You can't sort of switch it to go to the grid instead of your home or anything like this. It's just an instantaneous thing that happens.
Okay, so if the home is not drawing that much power, surplus power from the solar panels will go to the national grid, where it will be drawn to power your neighbours' homes. You can be paid, as we've discussed, for the electricity that you export to the grid, but many customers opt for a battery storage system to complement their solar panels because they find the savings are greater than the export payments. It's important to note you will also continue to export to the grid once your battery is fully charged. We talk a little bit about battery systems. So solar home batteries are now very popular since the decrease in revenue from the feed-in tariff. When a PV system begins to export power to the grid, a sensor detects this and diverts the power to the battery for later use. Batteries store DC electricity, so they need an inverter to convert the DC electricity to AC electricity for us to use in our homes. This is where you will hear the term hybrid inverter. So a hybrid inverter is a solar PV inverter and battery inverter in one box. There's less conversion of electricity because it can be stored as DC electricity in the battery if the house is not using power.
So just to make a quick point, in the first instance, when if anyone's got a solar PV system at home, or they know someone that's had one for quite a while without battery system, you'll just have a solar panel system with a solar panel inverter, and then that connects to your fuse board. If when batteries first started to come out, mostly they were AC coupled batteries, which meant you then had a separate battery inverter and battery. Now we still use these today because it can offer some more flexibility than using a hybrid, but typically most customers have a hybrid inverter. That might be something that we might get a question on later. So essentially a hybrid is a two-in-one box. It's a PV inverter and a battery inverter.
Okay, so if we just look at these diagrams, so if on the left, if you're generating excess solar, so there's nothing more to power into your home, the solar energy will go down to the grid. If you are needed, you've used all your generated electricity and you still need more, then you will draw power from the grid. And unfortunately, solar panels don't work at night time, so during the night time you will either use power from your battery if you have one, or you will need to use power from the grid.
So yeah, exactly. Just going back to that a little bit again. So the way that the electricity is distributed is instantaneous. There's no switching to choose, the house or the grid or anything like this. It's all just an instantaneous action.
Okay, so Gary's going to talk you through a recent case study of a family 4-bedroom home in Marlow.
Okay, so well, we've got many family homes in Marlow with systems. Typically, if for example we had a 4 kilowatt peak solar panel system, that would generate roughly 3,400 kilowatt hours per year, which is roughly 9.3 kilowatts per day. Now that's a very straight down the middle average figure, but of course this will differ greatly in the summertime to winter time and different days. But going straight down the middle, on average, it's 9.3 kilowatts per day. Now, although the electricity usage in the house is around 10 kilowatt hours per day, so roughly around the same, they are probably still only managing to save roughly 50% of what they can generate with their solar panels, because they're not able to use the power when it's being generated. Most people will find this because a lot of power gets used when the ovens and things come on at 5 o'clock or 6 o'clock, whenever you have your tea, and they use a lot of the power that you're using. So then they purchase a home battery system, which can store roughly 5 kilowatt hours of electricity, which is a good size battery. This is what our most common size that we supply, to capture more of the solar generated electricity from going to the grid. Even with a battery storage system, you will still likely send power to the grid, and especially in summertime, where you will still draw power from the grid as well in the winter times. It's important to note. So it doesn't completely, you don't completely go off grid, and also to say you will still get export payments even if you still have a battery as well. So, but it just limits that. Without a battery, it's quite extreme. You put 50% of your power down to the grid, and then obviously you'll be using a lot more power as well in the evenings and so on, of course. There's also still an art to maximizing the savings as well from your solar PV and battery system. So if you wait until the mid-morning to start running appliances, say for example you put the washing machine on first, and then wait until that finishes, give it an hour or so for the battery to replenish itself, and then and then you can put on the dishwasher or whatever else you need to put on. The reason for this is you may have, on a sort of semi-overcast day, you may have 1500 watts or 1000 watts of power, and the washing machine takes 2000 watts. Well, you're going to need those extra 1000 watts or 500 watts from the battery to supplement it, as well as your normal base load of around 250, 300, which is quite typical in the house. So you've got your live power from the solar panels, couple that with some power that's stored in the battery as well, and you can effectively run a washing machine or a dishwasher or whatever it is, and without drawing from the grid, if you're careful when you use things at a good time of day. And then, like I say, don't put everything on at once. Put things on one after the other and leave a little break in between. If you are really disciplined and you're able to do it, then you can become up to 70% off grid, so to speak, even in the winter time. And in the summertime, quite easily 95% or more off grid during the summer months. And this is what we're seeing with our customers. So here is an example with a pie chart, circle chart. This is actually taken from our monitoring package. So this is something that our customers actually have, and they can look back at their data and see how their system is performing. So on the left-hand side, you can see the total generation of the solar panel systems, which is 473 kilowatt hours for that month. Of that generation, they've been able to use just under 65% of it. 35% of it has overflowed and gone down to the grid. Now, on the right-hand side, you'll see the total consumption of the house. So you'll see that they've been able to basically use 75% from their solar and battery, and 25% has still come from the grid. So those are just those two figures there. And as you can see, obviously, there's still some excess going down to the grid, but then you've still got a bit coming from the grid. But mostly we're looking to be, in this example, we've given a very nice conservative figure here for winter time. This is 75% off grid, so to speak, without drawing anything. So you've also got the SEG payment there factored in as well. So that payment is showing there as just over £8 off the bill. So it's not too much. That obviously goes towards the money that you're going to spend that's been drawn from the grid. Okay. So the monitoring package, and this is the great thing actually. I mean, a lot of people ask me about how things have moved on. So as you might know, the solar panels have increased a little bit in output. When I came on board into solar in around 2014, we had 250 watt panels. Those were considered, the new premium high panel. They're all black as well, so look nice on the homes. And they've gone up slowly in increments of around 15 watts every 6 months or so. At the moment, pretty much the new high premium is a 400 watt panel. So those are going up in output. The panels are also slightly bigger, which you know, is a little bit of a red herring. But one of the main things I think that really is coming along quite nicely is the ability to monitor it and have insight into what is actually going on. In the past, with the feed-in tariff, you just had a basic meter and it told you your generation, and that was good enough. But now we're focusing on energy saving rather than just being paid off of the feed-in tariff. It really is key to actually understand, well, are you saving the power that you're generating? Is the battery full or is it empty? Can I put the dishwasher on? So this is where the monitoring packages are really, really good. Now these come with the inverters, and you'll see there, like on the mobile app, you've got like a little energy diagram there which shows power coming from the panels, the state of charge of the battery, how much power is being used in the house, and how much is being sent or drawn from the grid at that time. And you've also then got your accumulated data, which you can see the bar charts and graphs and everything there as well. These are typically, I'm able to see these as well. So one of my customers, I have like an installer portal. So quite often for the first sort of say couple of weeks, customers will send me the screen and say, hey Gary, check this out. You know, what does this mean? What does that mean? And I'll look at it and explain it to them. Also similar, if they think there's something wrong with the system, they can share that with me and we can like then remotely diagnose it. I could then go back to the technicians at the manufacturers and say, please take a look at this inverter serial number XYZ, and they can go in and see if there's been any sort of faults recorded or if the system's performing in a funny way. So, that is one of the key things I think people are very keen on now, and they expect. If you don't have that, it's we're back a few years in progress, aren't we? So really, it's a good thing. Okay. So how do they look? So yeah, it's very important to people, definitely. A lot of my customers have very nice homes, they're very house proud. It's certainly very important that the panels look nice. We take particularly, we spend a lot of effort in making them look nice. So in the first instance, what we'll do is we'll actually do a design, a 3D SketchUp model, and we'll be able to locate the panels on the roof. So it's done to scale, so we know exactly where the panels will fit and how they look. There's no like last minute sudden design changes on the day and things like that. So that, oh, actually we've ended up with a staggered array. We are actually able to put that kind of like nice block on the roof or copy the roof line as it looks. And we're able to fit all black panels. Pretty much 90% of the panels on the market now are all black. And then also as a nice little added touch as well, we paint all the rail end. We cut the rail ends nice and short, paint them black, and we put a, very importantly, we put a black bird mesh around the outside of the frames. So you can't really see underneath the panels. Everything's kind of nice and black and looks really nice and fitted and professional. Just to explain, actually, there's a little bit of difference here you might notice. So the customer on the left, Mr. and Mrs. Jones of Beaconsfield, that's an above tile fitting. So they, that's just a normal retrofit system. Same with Mr. Huxley in the middle. On the right hand side, Mr. Parker, he has had a huge extension and refurbishment to his property. And at that time, there was a brand new roof going on. So we were actually able to use the in-roof mounting kit. And then his roofer then tiled around it to give it that flush look. This is the system that we normally put on new build houses. We don't tend to do it for retrofits because it involves basically, taking the roof apart and you don't know what you can find. So unless you're prepared to put a new roof on at the time, we tend not to do it. We only really offer it for the new build customer. Okay. So here are pretty much the same sort of systems. We've got some slight different variations in the battery there. So what we can see here is the hybrid inverter on all three of these images, just with slightly different batteries. So typically we offer the 5.8 kilowatt battery. It's a really good value model. It's one sort of, say, solid lump, nice and neat, no sort of like ugly wires hanging out of it or anything like that, which a lot of customers like to see. Even if it's being stored away in a pantry or something like that, they still like to see it, right, as opposed to some of the other ones. The customer in the middle has got 2 batteries, so they are modular. You can have 11.6 or up to 4 batteries. And then the customer on the right-hand side, those are 3 kilowatt modules, same brand, but a slightly smaller module, and they wanted a tower of batteries. It just happened to be what was available at the time, and they liked the look of them. One thing to note about batteries is that a lot of people get told and ask for batteries to go in places that are not temperature controlled. So a lot of salesmen will say, yes, it can go in the loft. Yes, it can go outside. I'm going to say no, it cannot go outside. Well, it can do, but you're going to find that you're going to have some problems with your batteries if they do. So lithium ion will actually stop taking charge when it gets to around 5 degrees or near to that temperature, but it will discharge. So what that can mean is the lithium ion battery will start to go below safe operating temperatures, and the inverter will recognize this. Luckily, there's safety mechanisms built into the inverter, and it will force charge it from the grid to put, I don't know, say 20 or 30% into it, and then it will shut it down. So for that reason, it's really not ideal that batteries go in lofts. One, as you can see, I mean, they're quite big, very heavy. These are about 70 kilograms, each one of these. So not ideal for anyone getting up there if you need to service it. 1 minute, I'll take a drink. And as I said, they they do not perform well if they go below 5 degrees. And likewise, for that matter, if they go above 45, 50 degrees. So in a hot loft, not great in the winter when it's freezing cold, and not good in the summer either.
Okay, so we're going to move on now to the benefits of solar for the environment, which I'm sure there are many, but we've just picked a few points here. Obviously, it's a renewable energy source. Among all the benefits of solar panels, the most important thing is that solar energy is a truly renewable energy source. It can be harnessed in all areas of the world and is available every day, well, most of the days. We cannot run out of solar energy, unlike some of the other sources of energy. Solar energy will be accessible as long as we have the sun. Therefore, sunlight will be available for at least 5 billion years. And we won't be around anyway if the sun goes. So a standard solar panel in southern Britain saves 23 tonnes of carbon over its 25-year lifetime. Obviously, there's no emissions. Solar relies entirely on gathering energy from the sun and converting it into electricity for use in our home. Using it means you are not producing any greenhouse gases or contributing to global warming. It can reduce the carbon footprint of your home by 80% in 1 year. So that's quite a big number. Solar panels are incredibly low maintenance. So conventional heating methods require relatively regular replacement and maintenance, which can cause a lot of environmentally unfriendly waste, as well as the increase in need for more units to be made. Solar panels last about 50 years, so you shouldn't need to replace them for a really long time. And that goes to, any maintenance really. Solar panels are self-cleaning, so you don't really need to do a lot with them once they're up on your roof. We recommend, depending on environmental conditions, that you clean them every, 2 to 3 years?
2 to 3 years. I do have some customers that have a lot of trees close to the panels in proximity. So after the pollen season, it's recommended we go up and give them a nice clean, because you see there's quite a lot of pollen on the panels. These are customers with lower orientated panels. So they've typically been put on like a flat roof with just on a mounting frame with a 10 or 15 degree pitch, as opposed to some customers where they have a steep pitched roof at 40 or 45% degrees roof. These are able to sort of say self-clean a little bit easier, a little bit better, so you won't see as much build up on them as you will with a panel if it's sort of laying more flat.
That's us done. I mean, we have prepared some FAQs, but I think we'll probably hand back over to you, John, and see what.
This way, John tells us, did hear a word of that.
I'm going to stop sharing.
Oh, thank you very much, both Jackie and Gary. Yes, we're open to questions now. I can start you off by saying, how much does all this cost?
Well, mates rates.
There we are. Yeah, so our typical order value actually, and you'll find we are definitely, I mean, if not the cheapest, definitely the most competitive, if not the lowest cost on the market, because we don't have any salespeople. We have no no sales managers, no salespeople. We don't have to hire these people. We don't have a marketing cost. We do, all of our work is referral based. So there's absolutely zero costs of sales and marketing. Our price, I think our average order value at the moment is around 9,000. It goes between, I think it's between roughly 8,500, and I think I saw a large system the other day with an iBoost and bits all added on for about 10,200. I know that out there are a lot of companies will retail at around 11,500 to some of the higher ones around 16,500, 17,000 for similar systems.
Okay, thank you. Where's the next question coming from? Just stick your hand up and demute yourself, as it were.
Oh, hi, John.
Here. Oh, okay. Off we go.
Go on, Sam.
And I, just as a follow-up to the last question, for the prices that you quoted there, what's the KWP, and does it include battery?
Yeah, sorry. Yeah, very good point. So that would be for a from a 4 to 6 kilowatt peak solar system with a 5.8 kilowatt battery.
Thanks.
Can I just ask how much the battery is on its own?
So the battery comes as a kit with a hybrid. So you have a hybrid inverter, battery, and then the related installation. So I would say if you were to have say you had a 5 kilowatt standard PV system, just a PV inverter, that might come to around 6,000. And then with the battery, it would come to 9,000, 9,500. So the battery is at least a third to a half, around a third of the price. So they are quite expensive batteries.
Okay, Riyadh.
Oh, hi, Gary. We've actually got a system in place, which we had installed about 4 years ago. And basically over the years, we've come to kind of realize that we're not convinced the battery actually does anything. And it's fitted in our garage. And it was quite interesting in the point you made about lofts, etc. I mean, could it be that the garage is too cold and somehow the system has turned it off as you described?
So it would recover. So if, for example, if the garage was really cold, and where we had that really bad cold snap, just was a couple of them, what would happen is it would shut itself off whilst it was cold, but then as it warmed up again, the next day or hopefully the next week, it should recover automatically. Have you got any kind of monitoring with the system so you can tell how it's actually working?
That's part of our problem, to be honest. When we had it installed about 4 years ago, we were very sold on the kind of environmental side of it and wanted to do it for kind of eco reasons. And it has it's given us some I shouldn't call it fit, but whatever the feedback. We have got money back from it. We can see a clear savings, but we monitor via a smart meter. So indirectly we can see if we're taking from the grid, and therefore deduce that the PV is working. Therefore we thought, well, logically, if the battery was loaded and it was taken from the battery, once the sun's set, we should be able to put on a device and it should not be taken from the grid, but it does take from the grid. So kind of just circumstantial evidence suggests the battery is not actually, it's not fully functional, which leads to another question, it's kind of to you really, do you know of other organizations that would come and audit an already installed system which may not be working to its optimal design, because there are some other bits of it as well which we'd need some advice on. Is that something that you could do or somebody else could do?
Yeah, no problem. No problem. I did. I took a look for somebody else actually.
Okay.
They'd gone ahead with the company, and then not really had much contact with them since. And then, you know, so I went around and checked it out. You know, just went back over everything, explained what they actually had, and we found that the inverter manufacturer had a monitoring app. We were able to get that working, because that is one of the problems. And when I was with a larger company, I did notice this, that it's not easy sometimes to access the online monitoring software that the inverter has built in it. It's not as simple as like pushing a WPS button on the inverter, running and pushing one on the router, and then it just works, say presto. You kind of got to jump through a few hoops. You might need a dongle or something like that. But you know, you should be able to access some data. Do you know which brand of inverter you have?
It's down in the garage, unfortunately, but so no. I mean,
Okay.
but one of the issues actually is when the people installed it, they were very much installers, and they didn't really tell us. They didn't give us any advice. I mean, they were never informed there was any kind of monitoring thing. There was nothing that went with it. We just assumed they fitted it and it would work. And you know, for some years it was fine. It gave us some money back. We're quite happy with it, and you know, we did our bit for the environment. It pays about £250 a year. That's not bad. And we can see direct savings, as I say, by monitoring the smart meter. So it's only recently we've looked at it and thought, well, is it working to its full potential? So I might be calling you.
Yeah, no, very well. Please do. Yeah, that is one of the problems I've found with a lot of these companies. So the sales guy will see you once, he'll sell it. The installers will see it, and they just want to quickly fit it and then go.
Yeah.
They cover very, very large areas as well. So these people might have come from Essex or from even up north, and they're there to fit that item. So here you go, mate. Explain it very quickly for 5 minutes, and then get in the van and drive away. So you know, you do need, and I think a lot of solar customers, particularly now with batteries. Back when you just had solar panels and an inverter in the feed-in tariff, you look at your generation meter, is the light blinking and going up? Yes, that's it, pretty much. But with batteries, you need that insight, and going back to the monitoring, it's a crucial part of your system performance.
Yeah, we're never shown that. We're never even aware there was monitoring.
Yeah, well, I mean, there should be. We'll take a look and we'll see.
Yeah, okay, great, thanks.
So grab our details.
Okay, I don't want to hold your time. Thanks a lot.
No problem.
Okay, we've got a question from Charles and then Anne.
Hi there, Gary. It's Charles here. Hi, Jackie. Couple of questions. One's a simple commercial question. When you offer your systems, are you currently still able to offer them VAT free?
Yes, so it's VAT exempt for residential customers. For commercial customers, and I think, is that what you meant?
I'm involved in both sides, so I'm questioning you on. So
okay.
Yes, I know on domestic, yeah, but the inclusion of batteries. So if you take a hybrid inverter plus batteries plus that, and you were to try and push it to a commercial client, is it you still have to charge VAT or not?
So with a commercial system, we add the VAT, but then of course, you know, in the normal condition,
then it would just come back as a VAT input, and they claim it off their business, I presume.
Yeah, that's correct. Now, I just want to make a point actually with commercial businesses. We just installed a commercial system for a commercial unit in Princess Risborough, Aircon Services. They've got 30 panels. They are able to claim a grant, you know, the grant that everyone is, you know, you can't get it for a residential customer. There are actually grants available for businesses through the low carbon exchange. So if you have a business, and if you might be lucky, even if you work from home, you might actually find
this is one of the angles that I've been briefly pursuing. I'm in the business, but I've been advising a potential client, and as I started digging, I can see there's a loophole there, and it's a question of it I want to explain. Oh, we'll come back to that on another occasion. technically, since you've been in business for quite a long while in this game, one thing I wanted to ask you is: are you advising clients on any form of return on investment, break-even number of years or not? I've heard a lot of claims about, previous claims years ago, because of the feed-in tariff. Yeah, you can get a break-even. You can do it in 7 years, 8 years. My latest estimates, and manufacturers as well, if you kick off today, you're going to be lucky in 11 years to break even.
That very much depends on how much you pay for your PV and battery system. So yeah,
I'm working on your pricing, so 8,500 or 9,000 as a system, because what is not being explained to people, and I want the group to be aware of this, and you won't know with Solax because you haven't had them out there for 10 years yet. In a 20-year period, you will have to change your inverter. You will have to get a new inverter. I know from an electronics point of view, you are not going to get, you know what the warranty is, you know what the guarantee is. So in the model, the MCS sort of models and that, they should be adding in an additional cost, capital expenditure of a new inverter. And likewise with the battery.
True. That is true, yeah. So the warranty covered that. Well, we do explain the inverters come with a 10-year warranty, and the batteries have a 6,000 cycle warranty. So that is true. That is explained. Obviously, the PV panels, manufacturers give them a wild 25-year warranty now. Nothing really goes wrong with the PV panel. The inverter is the Achilles heel of the system.
Indeed, Gary, when I've done forecasts using software on that, which I do, that's why I make a statement to anyone I'm talking to. I'm not like you. I'm not running a company specifically that I'm in electronics and I'm in sensors and stuff like that. But 11 years comes because I know if I do the calculation and put a new cost of an inverter at a lower price, because in the future they'll be more beneficial and all the rest of it. But I think it's something that people need to be aware about. And of course, like Riyadh was saying just earlier, one of the main drivers for them was to be environmentally sound. It wasn't just a hard nose, let's save money. Mine is a hard nose, let's save money. And
most of our customers are.
Charles, can we move on to someone else?
I'm happy now, yeah, thanks for that. Thank you very much for that. Yeah.
That's all right, let's move on to Anne.
Oh, hi. I just wanted to ask about the whether you look at the CO2 emissions in the manufacture of your PV panels and the transportation, because obviously it's very green to generate the energy from renewable sources, but then there is also that other cost, isn't there? And I just wondered if you quantify that at all, if you look at different panels to decide on the ones that you supply, to make them, to check that they're the most or the least carbon emission way of manufacturing, I suppose.
Yeah, thank you, Anne. So we can offer our customers a choice actually. So most of the panels and most of the equipment these days it is Chinese made. Unfortunately, when the anti-dumping laws were lifted in Europe, the Chinese panels flooded the market, and the German manufacturers, one of the biggest ones we were using at the time, Solarbility, actually just went out of business. They just couldn't compete. So, but we are seeing now, we're actually able to supply from manufacturers such as Meyerberger, which is again back to it's a German and Swiss joint company. They have the highest standard of ethics. So the panels are produced with, with renewable technology. There's, there's a lot of other more proven, better ethical standards with them, as opposed to the Chinese counterparts. because with China, I mean, you know, that is true saying that we don't know. Although I have been to some of the factories in China myself personally, and I am actually, you know, pretty blown away. I don't think it's the China we thought it was, you know, 10, 15 years ago. It's very, very high tech, very clean, very safe looking, very, you can't, it's not somewhere where you sort of seeing anything done of low ethical standards. But yeah, I mean, there is a choice. I will say this though, obviously the panels made in Germany with, you know, with these guarantees about their, you know, standards and certainties are a lot pricier. And I think customers look at it and think, well, you know what, that's quite considerable. And a lot of people do opt for the Chinese panels, I'm afraid.
Yeah, understandably. Okay.
Yeah.
Thanks, Gary.
No problem.
Right. Over to Nick.
Oh, on me.
Thank you. Sorry. You may have explained this already, so apologies. You said that there's no switches about when you're exporting or importing power from the grid. If your generation exceeds your consumption, it'll go out, and otherwise it'll come back in. Are there any controls, or can one buy them extra to put on the battery to control when it discharges? So I'm thinking, for example, if you were on a time of use tariff, and between 6 and 7 p.m. when the whole country is turning its electric ovens on maximum national demand, the price of electricity can really shoot up. Could you control your battery to export then?
Yeah, you can. Good question, actually. I've got customers that do similar things. So with the monitoring app, you're actually able to go in and remotely diagnose and change settings on the inverter. So right here from now, if a customer said to me, "Oh, Gary," even if they didn't want to do it themselves, they could ask me, and they said, "I want to discharge my battery from 5 p.m. every evening for an hour," or maybe they've got an off-peak rate in the early hours of the morning. We can put charge into the battery at that time as well. So that is something. I'll just quickly press on that a little bit more, actually. So off-peak rates are generally awarded to customers with electric vehicles or with heat pumps. I've got a customer who's actually got 2 off-peak rates. One is in the early hours of the morning. The other one is in the mid-afternoon up until 4 p.m. And he's got a giant heat pump to heat his home with. So he manages to fit anything he's doing into those times. So he's basically heating up all his water and using his dishwasher, anything he can put on in those times. In fact, it was one of the customers where I showed you the 2 batteries. He then also puts charge in those batteries as well. He's a very, very high user. He could fit, I think it was 12 or 13 panels on his roof, but his usage way exceeds what the panels generate. So yeah, we can actually discharge the batteries on timers, on schedules, whenever you want.
Thanks.
Okay, super. I think we got time for one more question, if there is one. Anybody got a question?
3 people.
Eve.
4 people.
Eva.
Hello. No,
Oh, hi. It's Claudio.
Oh, hi there. I've got a question for you. If I have an extra battery, there is an advantage? That's one question. Second question is, I went to a customer's house today, had a big solar panel similar that you explained, the big battery, from a company called Solarcentric, and I was very disappointed with the workmanship. Like the lady had the system done more than a year ago, but the battery has not been connected. And the people you're trying to get it there. Even I tried to speak to the installer, and there's nobody in a company you can talk to. So my question is, if I do my solar panels with you for the batteries, when you get the installers in, because I know the installers, they get paid by the installation. So they do quick, go. And then who do you talk to? Do you come to actually check their installation? Because if someone doesn't know a lot of the system, they need a backup that the system is really generating the solar panels are generating electricity, the batteries are really working, is you're helping the environment, but at the same time, you want to make sure it's functioning. And when I saw that system today, I said, what's the point? It's like, so how different is your company?
Oh, right, yeah, exactly. So I set up this company, you know, to basically be the opposite of what is going on right now in solar. So obviously solar is a booming market right now. It's a really good industry to be in. But unfortunately, you know, with a new industry, lots of people fall into it from, you know, unscrupulous places. And you have, you know, there's a shortage of installers as well. So if you think about it, right, well, where are we going to find the installers? Who's going to train them? And how much are they going to be paid? Where are they going to come from? This sort of thing. So yeah, you know, you've got a, I'd probably say the majority of solar companies out there are large sales companies that are selling anywhere between probably 10 systems a week up to, you know, 50 to 60 systems per week, every week. And these are, you know, sell. They'll be selling at quite a high price as well, which is the odd thing, because you'd think the more you sell, the lower your price could be. But no, that's not the case. And in fact, you'd also think with the higher price, you'd get a better installation. It's not the case. I can assure you a lot of the money from these panels, you know, where you're paying 15,000, 16,000 pounds is going on the sales commission, and the installers are actually getting paid less. And a lot of the installers are not properly trained. They want to just fit the system and run away. And then the company itself is a sales company. The fitters and the salespeople are completely separate. There's nowhere in the middle. There's nothing in the middle. There's no meat on this company. It's just a sales outfit which sells it and it doesn't want to speak to you again. And then you've got an install team and you have no idea who they are. And unfortunately, that's the way, you know, there's a lot of companies out there like that. With our company, it's me. I will be out there installing your system. So let's just say, for example, if you said, oh, we'd like to go ahead with your company. Sorry, just got distracted there. So yeah, so if you wanted to go ahead, I'd come out and do a survey of your home. We'd discuss like things like the cable routes and what you'd be happy with. So you know, where you wouldn't want to see a cable, where you don't mind seeing a cable, that sort of thing, where you want the inverter mounted and situated, and then that would all be taken down. I would create a survey that we'd agree on. I'd share it with you so you could oversee it and agree to it. And then come installation day, I'm on the installation, so I'm there with the installers. I'll be working on the roof with the roofing guys, and who are my own guys who I employ. The electricians, this is where I differ slightly. So the electricians are guys generally that are just connecting the system into the consumer unit to give it that ticket. I've worked with them for about I think about a year to 14 months, somewhere around that. But it's the same guys every week, and it's only one of two guys that I have a great relationship with. Any technical aspect as well is also handled by me. So once the system is up and running, I'll be there with you. I'll be setting the monitoring package up on your phone so you can see it. It's all set up. You'll see it working. You know, we'll leave you for a couple of days. I'll call you. I'll check in on it. I'll see your monitoring working, and then we send an invoice later on after that. We take no deposit as well up front. You've got complete confidence in what's going on, because at the end of the day, you know, we're not going to invoice you until something's done and you're happy with it. Pretty much the same as, you know, as if you do business in any other way. So you'd wait until something was finished, it was working, we'd check it was working, make sure there's no glitches or bugs or anything you're unhappy with, and once you're happy, we'd send you an invoice.
Yes. As we're running out of time, can I suggest, Claudio, if your friend does have any problems, he hopefully could get in touch with Gary, and Gary would come round and sort him out. Ivan, I think you had a question, or Ivan?
Yes, if you don't mind, yes, Ivan. The question I have is just on the, you mentioned the different manufacturers of solar panels. Is there any sort of general movement of the technology within the panels, which were to make you choose one over another? apart from the environmental CO2 aspect you mentioned?
Yeah, sure. So with the solar panels, I mean, you may be familiar with monocrystalline or polycrystalline, and you had those differences there. That was going back about, say, 7-8 years ago. These days, you typically have monocrystalline perk cells, and they'll typically be the cut split cells. So a lot of the manufacturers kind of move along with the same technology at the same time. You know, they're all typically Chinese companies, like JA Solar, Canadian Solar is also Chinese. There are a couple though that are kind of independent. We don't really see that much of because they are, you know, they sort of price themselves out of the market. So there's Sun Power in America. Very difficult to get these panels over here, but you might find that they're pretty much, you know, at that sort of, say, cutting edge. They always have been. But in real terms, I mean, if you're looking to have a 450 or 430 watt panel over a 400 watt panel, would you want to pay twice for it? So again, with a lot of people, the offering we do get from these Chinese companies, you know, most people just say that that's, you know, that's obviously the one. It works out for us. It's a cost saving exercise, and you know, these panels are certainly good enough.
Okay. I think we've possibly run out of time. But before we go, I'm sorry, Riyadh. I know you've got your hand up, but
no, don't worry, it's okay.
We've run out of time. Just a quick couple of announcements before we go. First of all, our next talk is by Martin Fry from Esther Energy Conscious Organisation. I don't know if Martin's here and wants to add anything to that. Are you still here, Martin? It's evidently on the 10th of October, so you'll get information about this if you're on our mailing list. It may be a Zoom or it may be an actual live thing. We may go live for the first time for years. And the second thing is, on the 7th of October, we are hiring the theatre, the Shelley Theatre in Court Gardens, to run a smart energy show where we hope to get 20 or so companies promoting their particular technologies, whether it be heat pumps, PV panels, insulation, you name it, so that people can wander around and have a look and ask people questions of how much things cost, where they get things from, etc., etc. There's an outside possibility that Solarbility will be there. You never know. We hope for the best. Anyway, that's on all day on the Saturday, the 7th of October, from 9:30 to 4:30. So, in closing, can I thank very much Gary and Jackie, or Jackie and Gary, for an excellent and interesting talk. As I say, it is being recorded. It will go onto our website. So if you missed any of it or anybody wants to see it, they can hopefully access it in the next week or so. Thank you everybody else for attending. Hugely appreciated. Hopefully you enjoyed it.
Thank you.
Thank you very much.
Thanks, John, for organising it. Bye.
Thank you.
Bye.
Thanks, John.
Bye.
Bye.